Hello and welcome to part 4 of the video series. Today, we are going to take a brief look into the FreeRTOS. So, what's an RTOS? It stands for Real-Time Operating System. We call it real-time as the amount of time it takes to complete a task is always consistent, thus real-time. Meanwhile, a conventional operating system such as Windows or Linux usually takes a more non-deterministic time to complete a task. The key ideas and concepts in RTOS are as follows: multitasking and scheduling, message queues, semaphores and mutexes, timers, and event groups. I know there's a lot to take in, even for me. I had a hard time wrapping my head around most of the concepts. First, let's try to understand the spirit of RTOS, or why such a system is needed in the first place. A good analogy of an RTOS is a superhuman that is running a pizzeria. He's super fast and he could switch between being a cashier, a cook, or a waiter in no time. Let's think, what are some problems that he might face? For example, while preparing for a pizza, a customer might come in. This gives him a unique problem. Does he continue preparing the pizza, or does he take the customer's order? Which task will take priority? And after that, let's say he proceeds to bake the pizza. Should he do another task such as cleaning up plates, or just wait until the pizza finishes baking? And finally, how does he keep track and update the list of customers' orders while handling all these tasks? These problems are analogous to what a single-core embedded system would face when handling multiple tasks. How should a given system react to a user input while, let's say, drawing a GUI? Should it do another task while waiting for sensor data? Or how does it ensure that the data among tasks are up to date and handle their inter-task communication? So, these are some of the problems you are trying to solve with an RTOS. I hope that gives you a better picture of the situation. Alright, without further ado, let's jump and take a closer look into the code. This code pretty much just blinks the LED. But there are two new functions in the main program: task create and task start scheduler. First, let's look at task create, which creates tasks, allocates stack memory to it, and its priority. It takes in 6 arguments: the task function, the task name, which is not used much but more for code readability, stack amount in words, where a word is 4 bytes, so 100 words is 400 bytes. The parameter data to be passed into the task, which is null in this case, since we don't need to pass any data into the task. Task priority, where it is 1 in this definition due to the fact that there's only one task. And finally, a variable for task handle, so we can keep a reference of the task and operate on it, such as deleting the task or change its priority level. So, to sum it up, it creates a task called task 1 with a stack memory of 100 bytes and the highest priority. Next, let's take a closer look at task 1. It still contains the same code as blinky 1, except it uses the task delay function to do nothing. But this delay function is special, as instead of blocking the entire code and wasting CPU time, it will instead look for other tasks to do and not waste precious CPU time. The task start scheduler basically just starts the scheduler. Without it, the tasks won't run at all. One last thing before we close this summary is the FreeRTOS config file located in the same working directory. This allows you to adjust the parameters of FreeRTOS to suit your board and needs. For example, the CPU clock is defined as 72 MHz, which is the speed of the blue pill. Another thing to take note of RTOS is naming prefixes and macros. FreeRTOS functions are prefixed with a letter, indicating the variable type that it will return, such as vTaskScheduler, which is just a task that returns void or nothing. And then there is the macro prefixes for variable definitions, which indicates which file the definition is stored under. That's a lot to take in, and there is more coming up. So let's end this chapter summary here. Thank you for listening, and keep on learning.